I'm Dr. Krishna. I am Assistant Professor of Sri Kerala College, Thrissur. I am going to teach you matrices. A matrix is a rectangular array of numbers arranged into rows and columns. And matrices are represented by capital letters A, B, C, etc. And here A is the matrix 2, 4, 6, 1, 5, 8. And B is the matrix 3, 0, negative 10, 7, negative 9, 1, 0, 6, 2. Then in the matrix A, there are 2 rows 2, 4, 6 and 1, 5, 8 and 3 columns 2, 1, 4, 5 and 6, 8. In the matrix B, there are 3 rows 3, 0, negative 10, 7, negative 9, 1, 0, 6, 2 and 3 columns 3, 7, 0, 0, negative 9, 6 and negative 10, 1, 2. Then these 2, 4, 6, 1, 5, 8 are called entries of the matrix A. Similarly, 3, 0, negative 10, 7, negative 9, 1, 0, 6, 2 are called the entries of the matrix B. And now we can write A11. First row, first element. First row, first column element is 2. So I can write A11 equal to 2. First row, second element is 4. So I can write A12 equal to 4. A13 equal to 6. A21, second row, first element is 1. So I can write A21 equal to 1. A22 equal to 5. And A23 equal to 8. Next, how matrices are used. That is, I am going to show you. Suppose I go to Elite supermarket and bought 2 kgs of apples and 5 kgs of oranges and 7 kgs of grapes. And then I went to Kalyan hypermarket and I bought 7 grams of kgs of apples, 6 kgs of oranges and 4 kgs of grapes. This situation can be represented in matrix as 2, 5, 7, 2, 5, 7 first row and then 7, 6, 4. Similar situations we can represent it as matrices. Now, matrix order. If there are m rows and n columns in a matrix, then we say that the matrix is of order m by n. We write it as m into n and we read it as m by n. Suppose A is 3, 7, 9, 0, negative 6, 5. Then there are 2 rows and 3 columns. So order of A is 2 by 3. Order of B is 3 rows and 3 columns. Order of B is 3 by 3. And order of C is, since there are 2 rows and 1 column, order of C is 2 by 1. And order of D is 1 by 1. Then matrix addition. 2 matrices are conformable for addition if they are of the same order. Suppose A is a matrix of order 2 by 3 and B is a matrix of order 2 by 3. Then only we can add these 2 matrices. Addition can be done by adding the corresponding entries. Suppose A is given as 3, 0, negative 10, 7, negative 9, 1 and 0, 6, 2. And B is the matrix 7, 6, 10, negative 5, negative 9, 1, negative 6, 2, 8. Then A plus B is equal to 7. 7 is got by adding 3 plus 4. Next element is, that is A11. Now what is A 0 plus 6. Next, this is 0 plus 6. Here, negative 10 plus 10. That is 0. Now 7 plus 5 is written here. 2. Negative 9 plus negative 9, that's negative 18. And 1 plus 1, 2 is written here. 0 plus 6, negative 6. 6 plus 2, 8. And 2 plus 8 equal to 10. That is how we are doing the addition of matrices. Now, matrix multiplication. The product of matrices is possible if the number of columns of the first matrix equal to the number of rows of the second matrix. Here, A is of order m by p and B is of order p by n. Then A and B are conformable for multiplication. We can multiply A and B since number of columns of A equal to the number of rows of B. Then A and B are conformable for multiplication and order of AB equal to m by n. For example, suppose A is 3, 0, negative 10, 7, negative 9, 1, and 0, 6, 2, and B is the matrix 2, 8, 1, 0, negative 7, 9. Then order of A is, this is a 3 by 3 matrix, A is a 3 by 3 matrix and B is a 3 by 2 matrix, 3 rows and 2 columns in B, 3 by 2 matrix. Then order of AB is 3 by 2. Order of AB is 3 by 2. And ijth element is obtained by A11 is the product AB. First element is first row, first column element is first row into first column. We have to do first row into first column. Cross multiplication of first row and first column. That is 3 into 2 plus 0 into 1 plus negative 10 into negative 7. That is 76. Similarly, we can do all and find the product. And there is special type of matrices. One is square matrix. A number of rows, if the number of rows is equal to the number of columns, it is called a square matrix. Then idempotent matrix. A square matrix A is said to be idempotent if A square is equal to A. That is A into A. If you find A into A, then you will get A. Then it is called idempotent matrix. And some applications of matrices are we can represent many life situations using matrices, as we have seen in the second slide. For finding solution of simultaneous equations, if we are given equations, we can represent it as matrix form, and then we can solve easily. And for coding and encrypting messages, graphing software such as Adobe Photoshop uses matrices to process linear transformation to render images. Worldwide situations like population of people, infant mortality rate, etc. can be represented by matrices. These are some of the applications of matrices. You can find more applications. I think you all understood the topic well.